See, this question says that a man travels 3 meters due east. So 3 meters due east means this is, let's say the person has traveled, the first displacement is 3 meters. Then 4 meters towards north. S2, this is covered is 4 meters. Now you have to calculate the net displacement. So how do we calculate the net? How do we calculate the resultant? How do you calculate the displacement? You join the initial and final portion. Yes, very good, Yasir. So you have to find out this. Now see, what is the angle that is being formed? 90 degrees. Yes. So in one line, you'll have the answer. Like Yasir has answered it very well. 5 meters, they are forming Pythagorean triplets as well. So 3, 4, 5, they'll form a complete answer. So your resultant will be under root S1 square plus S2 square. These types of questions we had seen in the last class. It's just that you have to know the application of triangle law. So this becomes under root 4 square plus 3 square, which is 5. Right, 16 plus 9, you're 25, root 25 is 5 meters. Yes, I was saying, see, the answer is not complete. This is just the magnitude of the displacement. We have to tell tan beta also. Tan beta will be the complete answer when we have to define it. So tan beta, see, tan beta will be equal to, we have to write perpendicular divided by the base. So perpendicular, that is your b vector. B by a is left, no, because b sine theta divided by b, a plus b cos theta. Cos 90 will be 0, so no need to write. Sine 90 is 1, so again no need to write that one. So you are left directly with b by a. We have seen these cases in the last class. So this directly becomes 4 divided by 3. Vector b by a. That is vector b by a, which is 4 by 3. So your beta is tan inverse 4 by 3. So your complete answer is displacement is 5 meters with beta as tan inverse 4 by 3. See, this part says that if 3 vectors represent the sides of triangle, if 3 vectors are representing the sides of triangle in the same order, yes. Right now, I have told you, no, when you are using triangle law of vector addition, one vector gets oppositely added, right? We take the resultant in the opposite direction. Vector A is there, vector B is there, and the resultant is present in opposite direction, in opposite order. That is your triangle law. You have written also in your notes. So when you have 3 vectors in the same order, then your answer directly becomes 0. Means if I have this, then vector A plus vector B plus vector C is 0. Fine. Make this as a note point and write down this question also. Then we'll come to polygon law. I didn't go. C class. Last is polygon law of vector addition. So again, same rule, same law is there. You just have to remember how to represent it and when to use and how to identify. Your common law is parallelogram law that all of you should know. You will see even in your 12th class, you will be having chapters like electrostatics. There also again force will come. And when force comes, when the electric field you will have, that is also vector quantity. So as soon as you have vector quantities in your syllabus, then you have to apply all these laws. That's why we are studying these basics. So mainly you have to use parallelogram law, but if you are seeing that more than two vectors are given, that time you cannot use parallelogram law if they are given in the same order. Like if I give you a vector like this. So they are multiple vectors which are acting in the same order at a particular point. So their resultant is given by the closing side of the parallelogram taken in opposite order. This is the resultant. So you have vector A, you have vector B, you have vector C, you have vector D. But how to solve it? In our formula is again the same. Again the same formula. Under root A square plus B square plus 2AB cos theta. Same formula for tan beta also. How will you solve? You will solve them first. Like you solve the triangle law. You will get the resultant, right? Here you will get the, then you will solve this. Then you will solve them, you will get the resultant back like this. Polygon law hardly gets used. One last question is there, which I think came in your assessment also. I'll discuss it. Or let me discuss it right now, only then you can note. So, see, if it says no, magnitude of vector A plus B is equal to magnitude of vector A minus B. This means when I say magnitude of A plus B, it means I am adding two vectors and taking their magnitude. How do I take the resultant's magnitude if two vectors are getting added up? Remember, this was a special case I made you write separately. We had written three cases: parallel case, anti-parallel case, and perpendicular case. So this is under root A square plus B square plus 2AB cos theta. This is given equal to A minus B. This also we had written, that is A square plus B square minus 2AB cos theta. See, root will get cancelled. So we will be left with A square plus B square plus 2AB cos theta is equal to A square plus B square minus 2AB cos theta. A square B square will get cancelled. See, if 2AB go there, this becomes 4AB cos theta is equal to 0. Cos theta will be equal to 0. When do we have cos theta as 0? 90 degrees. So this question is very important. This comes a lot. This gets repeated. Note this down. Then we'll start with the resolution of vectors. That is also very important.
And do we note down polygon also?
Formula is the same. Formula is the same.
No, do we know this law?
Yes, you should just know this law. In case your paper is difficult. See, again, I'm telling you, usually, your paper, half the paper gets solved with your parallelogram law. But polygon law and triangle law are present in your syllabus. So that's why study it once. But when I give you important topics, I'll suggest that is your parallelogram law, the most important topic. Derivation also, that will come from parallelogram law. Just in case if a question is given where you are seeing this, then you can apply polygon law. All right, Martin?
Yeah, ma'am. Okay,
Yes. So coming to resolution of vectors. See, resolution of vectors is not difficult. You have to know how to break up the vector if the vector is given to you. Suppose if I give you a vector, let's say I have given you a vector A. So vectors have two components associated with them. One component, let's say A1 vector, another component A2 vector, and these have some angle between. This is A1. This is component of vector A. Fine. Regular components. These are regular components. Like if I want to get my vector A back, I will add A1 plus A2. I'll get A back. Fine. If I add A1 plus A2. Now see, we have no in our syllabus, in our 11th and class 12th syllabus, we do not have random splitting of vectors. Resolution of vectors means you are splitting the vectors into its components, these components. But you have a very special case in your syllabus, which is known as rectangular components. That only you have to focus on for your class 11, for your class 12, even for your entrances also. You just have to focus on that. Rectangular components. These rest of the components with different angles, you don't need to worry about it. How do we know what are the rectangular components? In rectangular components, we mainly resolve the vector along x and y axis. Means you are having 90 degree as the total angle. In between the angle can be anything, but the total angle, suppose this, say, let's say this is 4 Newton. Let's say this is 3 Newton. And the main resultant vector, it is 7 Newton. So 4 Newton is one component of 7 and 3 Newton is the second component of 7 Newton. Means if you add 4 Newton plus 3 Newton, that will give you 7 Newton. Fine. So these are the two vectors. Why? Why are we naming them as rectangular vectors? Because they are making an angle of 90 degree over here. You are having, even if you interchange them, 4 Newton, 3 Newton, they will, this is, let's say 7 Newton. This side one angle will be there, or this side one angle will be there. Suppose, let's say, let me give you an example. Suppose this angle is 30 degree. This is, what did I take this as? Let's say, let me take it as random. Let's say this is some x. Let's say this is some x. This is 30 degree. Rectangular components, because the total was 90 degree. Just this part is 30 degree. The angle that the resultant makes with one of the components. So I have to find out what is its component along x-axis. This is my x-axis. And what is its component along y-axis. 34 where? Which answer? 34? 30 degree, 30 degree. I have taken 30 degree. Just a random example. This is not definite something. So along the axis with which the angle is being made. Yes, not, yes, just an example, just a random example. Yes. The proper questions we will see. This is just a random example. X, Y, 30 degree with some value X I have taken. So along your X axis, this whatever component, the axis with which the angle is being made, that gives you cos theta. So the resultant multiplied to cos theta. This is my X. And the perpendicular one will be sin theta. So X cos 30 degree is the X component. Y component will be X sin 30 degree. Let us see this properly. See, this you have to understand it very well. This is vector A given to, right? This is your x-axis, this is your y-axis, this is angle theta. Fine, how do we have? This is the resultant, this is angle theta, like this. When I have to find the components. I just have this vector A and I want to find out the components along X and Y axis. Because if I solve along X and Y, then only I'll get the rectangular component. So how will I get my answer? The axis with which the angle is being made. Axis with, see, angle with axis is your cos theta, and perpendicular to it is sine theta. This is just the rule of your resolution of vectors. Angle with the axis, which is the axis and which is the angle? This is the angle, and is it with x axis or y axis? We can clearly see this is with x axis. So this becomes a cos theta. This is the component of a along x. What about y? Now the next one, ay will become a sine theta. This is how you resolve the vectors. If you have this resultant, this becomes r cos theta, this becomes r sine theta. This is how we have to solve the vectors. Suppose, let me change the angle. Let me give you another example. Suppose again, this is my a vector. This is theta, this is y-axis, this is x-axis. So now, angle with axis, we take it as cos theta. So angle with axis is this now. So this will become your AY, this time this will become cos theta. And the perpendicular to it, this AX, this will now become a sine theta. Why did we reverse it? Because the angle is made with the y-axis. So y-axis will have cos theta and perpendicular to it will have sine theta. This is just the basic rule of it. This is how you have to resolve the vectors, and all of your questions will be solved. Especially in laws of motion, you have this resolution of vectors so much in, you must have seen motion on an inclined plane. Inclined plane is their box is kept. When you draw the free body diagrams, you have to resolve everything by yourself. All right, note it down till here. We'll practice some questions.
Yeah, ma'am. Done. Ma'am, can you go back up? Oh, okay. Can go. Now what is written there? 4 1x.
Where this part? This.
No. The other graph. The x-axis. Sorry, y-axis. What is written?
This is 4 Newton. This is 3 Newton. And this is 7 Newton. Please write down this question, then we'll discuss it. First, note it down. I'll discuss it in the class itself. See, class, now we have three forces, F1, F2, and F3. So F1 is along the XY plane, right? And F2 is also along XY plane, but negative x-axis and positive y-axis. And F3 is along the negative y-axis, right? Now see, we have to resolve everything along x and y, right? Along x-axis and along y-axis, we have to find out the components. So see, do we need to resolve F3? Yes or no, according to you? No, right. See, F3 is already along y-axis. So why do you need to resolve it, right? See, F1 is along the XY plane. That's why we have to resolve the vectors. We have to find its component along X and Y axis, right? Now see, coming to the first vector F1, let us resolve this. Let us start with you, Sarah. So one component, see if we resolve it, one component will be this and one component will be this. Please tell me its X component, Sarah.
X is equal to sine theta.
X component will be see, angle is made
I
with
can't
the
hear
axis.
you.
So we'll have,
Can you say again?
what we'll have?
X is equal to sine theta.
See, check
And
it out
y
in the notes. Angle with which the axis is being made. Do we take sine theta or cos theta?
cos theta.
Cos theta. So your vector, now tell me the complete answer.
A cos theta.
What is A?
The
The
vector.
vector. So what is the vector here? Look on the screen, it's drawn. What is your first vector which you are resolving?
10 Newton.
10 Newton, right? So A cos theta instead of A cos theta क्या होगा? 10 cos.
10 cos theta. Yeah.
ठीक है? See, your this force is F1 cos theta. This is how you resolve, no? A cos theta. So that becomes 10 cos 30 degree. That is 10 into root 3 by 2, which is 5 root 3 Newton. So you have 5 root 3 Newton on this side. Yes? Next is Siddiqa. Y-axis, component of F1 along y-axis. Siddiqa, see F1 cos theta Sara has answered. What about y-axis? Siddiqa. You there, Siddiqa? Yes, no? Sin theta. Very good. So it becomes now F1 cos theta was here. So this becomes F1 sin theta. This means 10 into sin 30 degree. That is 10 into half, which is 5 Newton. So see, 5 root 3 plus 5 Newton is giving you 10 Newtons here. This is how you resolve your vector. So F1 has been resolved. Coming to this vector F2, one component we'll get on the x-axis, second component we'll get on the y-axis. Yes, Humamuddin. X-axis, component along x-axis.
F2 cos theta.
F cos theta, 5 cos theta.
Yes.
So complete what is theta here? 37 degrees, right? So this is F2 cos theta 2. This is theta 1. That becomes force is 5 into cos 37. So 5 into 4 by 5. 5 gets cancelled. You get 5. Martin, component along y-axis.
Y-axis.
X-axis, we have F2 cos theta 2. Along y-axis, see perpendicular to it, what do we get? Perpendicular to the cos theta component. What do we get, Martin?
Perpendicular to cos theta.
See in the notes you have written it somewhere. The axis with which the angle is made, that you consider as cos theta. So I have considered, Humam has answered that this one, because the angle is being made with the axis, that's why we have taken this as cos theta. What about this axis now?
Sin theta.
Sin theta, 5 sin 37. This becomes 5 sin 37 degrees, which is 5 into 3 by 5. That gives 3.
3.
Yes. So we have resolved every vector. Let me draw it separately so that you are able to understand. There I just made the calculation. See, everything I am resolving along y and x-axis. Along positive x-axis, what all do we have? Along this axis, we just have one quantity, this 5 root 3 Newton. So we have, here you have 5 root 3 Newton. Then along this axis, you have two components. You have 3 Newton and you have 5 Newton. Yes, these two components. One you have 5 Newton and one you have 3 Newton. Coming to negative x-axis, do we have anything? Yes, 4 Newton. And coming downwards, yes, that we didn't need to resolve, that is 2 Newton. So this becomes 2 Newton. Now this is your simple addition subtraction which you have. Let us just solve x-axis. See, both are in opposite direction. How will you solve fx? Subtract both of these. 5 root 3 minus 4, because they are in opposite direction, and this axis is negative. Y1 is negative. That's why we are taking 5 root 3 minus 4. So you can actually put the value. What is the value? 1.73234. 1.732 we take minus 4. So this will be around something 8.66 minus 4, that which will be around 4.66 Newton. So 4.66 Newton is the net force along x-axis. 4.66 Newton. This is just the force along x-axis. And what about y? Here we have here you are having, and one force you are having like this, right? One we are having like this. So here you have 8 Newton over here. Let me write total. And here you have 2 Newton. So 8 Newton and 2 Newton, they are in opposite direction. So Fy will be 8 minus 2, which is 6 Newton. Means along y-axis, you are having 6 Newton. Actually, it would be in the opposite direction because the resultant is upwards. No, that is of higher magnitude. So what are we left with? On x-axis, we are having 4.66 Newton. On y-axis, we are having 6 Newton, right? Now, this you know how to solve. We had 3 forces. Now you just have 2 forces with the angle 90 degree between them. What will be the resultant? 6 Newton, 6 square plus 4.66 square. This is your resultant. Whatever answer it comes, you can check. And for the direction, you will draw up this beta. This is the resultant. You will draw this beta. So your tan beta will become 6 divided by 4.66, from where you can calculate the value of beta as tan inverse 6 by 4.66. This is how this you can calculate later. No need to even calculate it. This is for your understanding. But see, your question was, one was this force, one was this force, one was this force. And see how have we used them and ultimately got our answer back. Right, note down this.
Can you go back up? Yeah, you can go down.
Class, text me done once you have written. All right, class, please appear for your after class assessment. Then now we are left with dot product and cross product. These two are only topics that we are left with. Yes, class. On Sunday, you people have your extra class. Not Humam. Humam, you don't need to join on Sunday's class because one class you already have from 3:30. Right, Humam? Others, Abdullah, Martin, Yasir, Sara, Siddiqa. This Sunday, I hope you have your vacations now. You don't have to, anybody who has to go to school. I hope you are having your leave because I had asked you earlier only.
Yes, ma'am.
Right. So 1:30 we'll have the class, 1:30 IST on Sunday. 1:30 IST we'll have the class. Humam, if you have the capacity, if you think you'll be able to join from 1:30 and attend your class till 5, then you can, but otherwise you can leave because already you will be having your class from 3:30. So 1:30 to 1:45 we'll start the class. So 1:30 on Sunday, this Sunday, because otherwise, see people, let's complete with vectors quickly so that we can start with motion in a plane. Will take just two classes because it's a very short lesson, 2 to 3 classes. It's actually very short. The rest of the part major is vectors only. Rest of it so that we can now start with laws of motion because it's high time now, right? So that's why let us have the extra classes till your vacations are going on. Okay, class. So please be present. This is not a subsidiary class or a backup class. It's your regular class. After Thursday, before we are having the class on Tuesday, we'll have this class. All right. Thank you so much. You can leave. Now we'll continue this on Sunday.
Thank you, ma'am.